Well, I find doing small hand nose radius is not the easiest thing to do, but it's easier than trying to do it nose on the tip here. It's easier than trying to do it setting it up in a machine. That takes a long time. And there's only about 5 thousandths nose radius on this here. I check with, hold on, let me lock the arm here. I check with these Peak SPI scale loop. This one's a 7 power, and it's got the scale in there. I don't know if you can see, but I just bring the tip up to those the appropriate mark. And I'm going to increase the nose radius to about 15 to 20 thousandths instead of 5 thousandths. So I'm going to help it along with this diamond wheel. Like I said, I'm doing it by hand because it's faster. So I've got this elaborate setup here. Let me scan that a little bit. That I come up with a rest here for the back side of this grinder, which is normally not used, and this just snaps right off, so I can, change it as needed. But it's a fully adjustable rest that I can present tools to different wheels by hand, usually to deal with those nose radiuses. So I'm showing you how I'm dealing with nose radiuses at this time. I may get a grinder. I'm really contemplating it for doing nose radiuses on end mills. It would be a monoset type, but I'd like to find a lighter weight one, and I have. I've actually found a couple of them that are very similar to the monoset, but let's see how I'm doing here. Get the light over. I think that light's probably pretty good, and I'm going to start the grinder, and I'm just going to start that nose radius. And I hope you're all doing good this morning, and I hope your nose radiuses go good. There we go. This 150 grit 5-inch diamond wheel. Let me see, I figured out that if I set it just about like that and just ease that nose radius in, I don't want to go too much because I'll have to back it off. I think that goes too much of a tail. Let's see if I can see it, if you can see it. Very hard to see it. Need to go a little bit more. I'm trying to be real conservative. Yep, I need to hold that block a little tighter. Let's see what that's looking like. I like it. I can work with that, okay? And we can see, if you can see what I can see. Let me get this, I got a magnifying lamp here. I don't know. Maybe I can put you down low looking up. Let's see if you can see that. And I'm going to look under the magnifier here. Let's see if you can see anything. Something, somewhat maybe. Now I'm just going to blend that nose radius in. Yeah, you can see that. And I'm just rolling that carbide over, and I start skating it, and it feels real smooth, and you just roll it just slightly, and you feel a little bit of drag, and that's where you caught the edge, right? I'm getting a pretty generous radius on there. I think you can see it forming. Okay, now I can tell you what it is by looking at it with this. I'll do that real quick here. And that nose radius is right at 20 thousandths. Now it's about 5 over, but I'm going to go with it because let's just see if I get a smoother bore over there on the milling machine. Oh, very sharp, very sharp. See it shaved thumbnail? Oh, okay, we'll get over there. Well, you know, old things need to be warmed up a little bit, and I believe in one video segment I did show dial indicator on here, and I was checking in play. And I ran this until this is warm, and there's no deflection now, where I was getting a couple of 10,000ths with a cold spindle. Keep in mind, now this stuff's 80 years old, but yet it's still precision. These are Timken Type 0 bearings, and I would expect the pair of bearings of this type to cost every bit of $2,000 in today's money. So, yeah, there's just, it's good. There's just virtually no play, and that's how it should be. So if you're going to try to bore a hole, you should run the machine for a while. I think I ran it for about 10 minutes. This housing feels a little bit warm, and that's normal. It's a grease lubricated spindle. Okay, so we'll get the boring bore in there. And I'll set the camera at a different angle. I'll be right back. You know, of course, a jig borer is a more accurate machine, similar to the Monarch 10EE being a more accurate lathe than the old axles in here. So you want to take more precautions setting stuff up, and that's where what I'm doing here, aligning this boring bar, is at least better than looking down it and trying to sight it in like a rifle or something. But setting it up this way on the jig bore adds better consistency. And you get in the habit of doing things like that. I'm going to go ahead and do it here. So I'm going to get the boring bore lined up. And here's the bar lip. That's drifting. I got a swivel on there. And okay, so I got that little reference dot right there. That's in the y-axis. You could have a scribed line and do the same thing. So let's see if I got that out of gear. walk around the side and get it out of gear. That's out of gear right there. So you can rotate it like that. And I'll get that square on there. Now, where did I put it? I put it so I wouldn't knock it down, and now I can't find it. Okay, I'll have to come back with the square. Well, hopefully Brylcreem didn't insert a commercial in there while I was busy looking for the square. So I got a square against the column here, and I'm going to bring it up against the lower part of the head here, because this older style has this clamp, and it might not be exactly square with the way of the head. So I'm going to go on the lower portion, and you'd have to do that with the round heads, like your standard Criterion or copy round head. You'd have to gauge it at the lower part. Okay, let's see how we looking there. That's really pretty good there. I checked these old squares like this one with master squares. And I'll actually take a needle file these things until they're square. And it's not that hard to do, but I check them quite often. And this is a lot better than kicking around the master squares. Though I have an old beater I kick around here. Okay, so that is square, or square-ish. Okay, now the boring bar goes this way. The dial's that way. Let's see if I can slip it in. It's a tight fit. Now I make these boring bars, and this one's kind of ugly, but it's got a great piece of carbide brazed on it, and I usually use oil hardened drill rod. This is like a 1/2 inch shank, so it's a 1/2 inch oil hardened drill rod. Now this aluminum tool, I don't know if you can see it from that angle. For aluminum, it has a lot of top rake on it. Okay, I'll start snugging that down. With that drill rod, unhardened drill rod, is kind of nice for this application because the shanks will be accurate. Just almost at the other outer edge of that dot. How's that looking? Because I kind of move it slightly ahead to account for torsion. You got to be picky, right? Well, this does help eliminate some variables. I got to get it on the other side. I think it's worth doing. I really do. Okay. Looks perfect right there. See what I can do here about snugging that in. Okay, we're good. Yeah, looking good. Okay, I'll crank it on over. I gotta move this. Okay, I'll get a better angle on the camera. All right, gonna clean up that hole there and start that two-step process again. Here we go. We gotta get it in gear. There it is. Okay. I think I might have a little clearance problem there I got to take care of on that tool. Okay, gonna just do the best I can with this situation, and I got the dial bore gauge set close to 0. It reads within a tenth or a half. The finish is a little rougher, but it burnishes in a little bit when you rock the gauge back and forth. Now 0's right at the bottom here. Let's raise it up some. See, that's showing about a tenth more. But you got to make sure everything's centered. See, that's showing a little tight, but it'll burnish in, see? We'll work it a little bit. There we go. So I'm measuring it, rocking it towards me. Keeping it centered. Just about minus a tenth or 50 millionths. But it reads within 2/10. So on that upper collar, the fine adjustment, I'm going to dial it in 20, which should remove 2/1000ths, and it should put the needle right there. Okay, needle set up right about the bottom there. Okay, so we'll get that set. I actually kind of enjoy doing stuff like this, and it'll give me experience with this head. Again, there we are. Sometimes it's kind of hard to see through this small screen. So I take the little wrench and find it. It's right here. Get that in and loosen it. And I found it matters how tight that is. You got to have that pretty snug. Now, leaving this bottom part alone and dialing in 20 10,000ths. Whoop, unscrewed the head a little bit. There we go. Got to see the mark. I'm going to call that very good. tighten the little screw. Had to shorten that Allen wrench, and I think I shortened 3 of them, and I kept losing them until I put that lump of aluminum on the end. Stuff that's small can get swept up. Okay, nice and snug. I'll make sure that's not going to come loose. That's on good. Okay. Now that it's sitting here, let's get a good lube in there. This wax really does work pretty good. Beeswax, Castrol, Molly D, tapping fluid, and a good dose of Tap Magic too. Steel. Okay, I've got to take it out of gear and get it past there. It's kind of, I think this microphone's going to work out good. I still have it safety pinned to my shirt. Get that thing where it's supposed to be. Make sure no plays in it. And where's my mark? Right there. Light locking on the y-axis. I did adjust the Gibbs just a little bit there. Okay. All the way into high. Okay, we dialed in about 1/1000th depth, and it should enlarge that hole 2/1000ths. So here it goes. See if I can get a little closer here. Now last time it cut it 1/1000th over, but I don't think I have the spindle warmed up enough. And that spindle's running 980, and I'm slowly hand feeding this in. It has a fine screw that moves the quill instead of rack and pinion. The finish is looking pretty acceptable. I got a mark up here, and I'm clear. Okay, stops on a dime and gives you 9 cents change. Crank that tool out of the hole. Let's get back here a little bit. That's a pretty good looking hole for such an old machine. Okay, now the hand is supposed to end up right here. Let's get a lower view here. Okay, dial bore gauge. This is the anvil, and you set that so you can get within the range. And you can set this with gauge blocks and a master setting device, or you can actually even set it with micrometer. What's it going to do? Now this time it cut 1/1000th under. Last time it cut a thousandths over. It's it's supposed to end up there, but there are other ways of going about this, and one is taking deeper cuts and forgetting the method that you need to do with the jig borer and just approach it with heavier cuts that kind of take a load on that rougher spindle, and I'll play around with that as I go. But I did everything that I did on that machine, and on that machine I got plus or minus 1/10,000th of an inch, and on this 80-year-old machine doing the same method, I got it plus or minus 1/1000th of an inch. But I think goofing around with it a little bit and taking deeper cuts than those real shallow ones you can take with the ball bearing spindles, I can get it to about a 0.5 thousandths. Now, like I said, I'm an inside machinist, and my ultimate cheat is that Sun and Honen machine. And I'm going to do a lot more on that. That's kind of a neat little item and a good arrow to have in the quiver. I'm going to go ahead and load this, and I'm going to give up hitting tenths on this old machine, but I'm pretty sure I can hit 5/10ths just using the regular dials on the head. Now, the one thing that's interesting about this head that I'm glad for, I'll put it right back onto a Moore shank, is that it has a lot more offset than the Moore head. And I'll show you that real quick, what I'm talking about. This is a standard head. Let's get that. Put that just a little bit right there, then I can move it, see? So I'm going to go ahead and loosen these screws, and I'm going to show you how much offset this thing has. These are the side plate locking screws. This is a nice combination to use on the jig borer. And I can just pop this head off too and use it without the collar on here if I want to, and it gives more range there. So the offset, of course, here's your adjusting screw. This is like the round heads except it's square. And we'll take and go ahead and advance it. Yeah, that does travel with it. It makes it hard. Still a tight fit. This is an older head, but it hasn't had a whole lot of use. I can't remember where I picked it up, but I've had it a very long time. And it's kind of handy. And I'll show you a different kind of boring bar to use in this. I hope I'm keeping that in the frame. I almost got it. This just doesn't want to fit in very good on this other end. There it is. You see that how much offset we've got there. That's more than a 1/2 inch. And when you get into these super precision heads, like the Moore, excuse me, the Moore head, you can see it's like its adjustment is contained right in here, and it's less than 3/8 of an inch, as I remember. Now, Ericsson made heads that were like this, and they also made heads that had adjusting collars. And there's quite a few heads like that. I think SIP or Dixie or one of the Jigborer companies invented the head with the collars. But these dial type with the vernier work very good. I've used the Ericsson ones and of course the Moore one here, and this is easily plus or minus 1/10,000th of an inch just using the vernier on it. But of course Moore, this thing here is made with extraordinary care. Okay, so what was that other thing I was looking for? Got so much junk around here. Okay, now if you want to bore a bigger hole, this is a boring tool here that I made, and these are really easy to make. You see how I made that? I made it hollow, and then I cut it away back here so you can grind it. Gives you clearance so you can grind it. And just off center, I cut a notch and brazed in a carbide blank right there. See that? Just use the bronze rod and it worked just fine. And so that's a cutter. And moving it back from center, see, when you rotate that to center, it gives you some back rake. I think I've showed some of that on the drafting table, probably on my other channel. But I'm going to be fabricating quite a few of these tools. I've got these in all various sizes. So, like, you can use this in the Moore head with that very little of adjustment and do bigger holes. And that's how you do that. See, with a head like this, it doesn't have the offset holes. And the reason you want to do that on a Jigborer in particular, and even this because it keeps it more rigid, is it keeps the head in balance and you can run it faster. Okay, I thought I'd just point out some of this and where I'm going with tool making. I hope you can see how this is. That carbide insert is just below center. So when it rotates to the center of a hole, you see it's got back rake. And you can adjust that. And you can adjust some side rake to it by how you put that notch in. You got full control. It's like I said, if you got a cutter grinder, you don't need to be buying a whole lot of tools because mostly everything's at hand. So I thought I'd throw that little plug in and kind of explain why I have a cutter grinder and not a whole lot of cutters, because I don't need a whole lot of cutters with a cutter grinder. Okay, I hope you guys are having a good one. I got a whole bunch of things to do, and I'll just keep doing it. And I think this microphone thing's great with the cord. The cord was at the dollar store. That's now $1.25, but you can't beat that. 4 feet of cord. And actually I can move around pretty good. You know, I can get reach about everything I need to on this tight shop. Okay, there's that cup of tea. I will be back.